Are you getting pressure from finance to justify or reduce your cloud bill? CloudZero is the only cloud cost platform loved by engineers and trusted by finance. CloudZero can identify unused, idle, or over-provisioned resources, alert you to spend anomalies, and organize 100% of your spend into a framework that mirrors your business structure, like cost per customer, product feature, or team. It's the most powerful platform ever built to provide accurate, granular visibility into your total cloud spend without the typical pitfalls of legacy cloud cost management tools like endless tagging or clunky Kubernetes support. Manage cost, optimize development, and maximize profit, all in one platform. Join companies like Rapid7, Drift, and SeatGeek by visiting cloudzero.com/cloudcast to get started. That's cloudzero.com/cloudcast. Visit today to experience immediate and ongoing savings on your cloud bill.
Cloudcast Media presents from the massive studios in Raleigh, North Carolina. This is the Cloudcast with Aaron Delp and Brian Gracely, bringing you the best of cloud computing from around the world.
Good morning, good evening, wherever you are, and welcome back to the Cloudcast. We're coming to you live from our massive Cloudcast studios here in Raleigh, North Carolina. And it is Aaron for Cloud News this week, and I'm going to jump right in. Really have two big things to talk about this week. One of them is OpenAI related, and the other one, which we're going to spend a good bit of time on, three things in particular, is Google Cloud Conference started today and the announcements around that. So let's jump right into the GCP announcements. So they announced a number of things, of course, as we probably expected. Lots of talks about AI, AI/ML, lots of talks about GPUs, as well as Kubernetes in the enterprise. And so, firstly, they announced Duet AI. So Google's AI assistant. I've seen different articles here, and by the way, I have links to 4 or 5 different articles in there. On this one, think of it as AI that will help with code, but optimization of code and changes to code, not full-on rewriting of code or writing of code. Think of it as taking code that already exists and optimizing that. That's one thing. And then there was also talk of, for a charge, an additional charge, hey, having AI that could also say do emails and things like that. I didn't find a lot of details on that second part of that announcement as much, so I'm not going to really dig into that one very heavily. But the Duet AI was really interesting. The use cases around it, very interesting. Definitely all designed to, of course, make developers' lives easier. And then as part of that, they announced more AI models. And they actually have brought the number of AI models that can be trained in Google Cloud up to somewhere around 100 off the shelf. And they announced also the 5th generation of the Tensor chip. So if you're not familiar with Tensor chip, more specifically, this is the lower end version of it. It's the TPU V5E. Designed to train large language models specifically, or large models specifically, but to be more efficient and to be kind of chained together, if you will. So you can actually stitch together batches of up to 256 to really make a quote-unquote supercomputer. And they also have said there'll be a higher-end version of the Tensor chip, kind of the flagship version, if you will, coming out later this year. Another one, because it seems like, no one can have a keynote without NVIDIA. Maybe we're going to have to make a drinking game like we've done with Docker and some of the others over the years. But, maybe if it's time for an NVIDIA drinking game, they were at VMware last week. And then, of course, VMware Explorer. And then now they're at Google Cloud and announced a partnership with them. And more specifically around getting Google Cloud better access to the H100 GPUs. So again, a good collaboration there, and NVIDIA stock saw a nice bump after hours because of that. Now, the last thing that I wanted to mention in talking about Google Cloud was GKE specifically. They announced what they're calling GKE Enterprise. Now, of course, GKE and just Kubernetes in general, kind of gets a bad rep at times for being very complex, and the bigger it gets, the harder it is to operate. Well, GKE Enterprise is going to hopefully solve some of that and also bring Anthos officially into the fold. So GKE Enterprise combines Anthos with GKE, and then also introduce enterprise-like features such as a fleet of clusters. And so think of all of the clusters in an organization. If you have more than one cluster, well, maybe you have organization or enterprise-wide policies that you want to set. And so you can apply these policies, create standard configurations for all of the environments. And so not just operate Kubernetes at scale, but fleets of clusters at scale. So that was one example they gave. And of course, full access to all of the new chips and services that were announced today as part of that. So with that, I'm going to close out talking about the Google announcements and flip over to the OpenAI announcement. Another announcement around enterprise. So ChatGPT Enterprise. So what they're looking to do is go, of course, ChatGPT was more of a personal or consumer level version. And they have, of course, taken a lot of funding and a very big valuation. And per Lightcap and OpenAI, they estimate 80% of Fortune 500 companies are actively using ChatGPT. So this is ChatGPT Enterprise. And the big difference here is, of course, enterprise pricing, big scale on something like that, but then also the ability to train the models specifically on your data sets. Now, I know there is definitely going to be some concerns around what happens to that data. How do you keep that data private? And a lot of that, I haven't seen a lot of details about going forward, but it certainly makes sense as a next step for the organization, and we're going to keep an eye on that. They also have said there's going to be a ChatGPT business model that is separate from this ChatGPT Enterprise. So think of this as the next step towards a larger model. So with that, I'm going to close out Cloud News for this week. And coming up after the break, we're going to be talking with Louis Ceze, co-founder and CEO over at OctoML, about the economics and optimization of AI and ML.
Today's show is sponsored by Panoptica. Panoptica simplifies container deployment, monitoring, and security, protecting the entire application stack from build to runtime. Scalable across clusters and multi-cloud environments, Panoptica secures containers, serverless APIs, and Kubernetes with a unified view, reducing operational complexity and promoting collaboration by integrating with commonly used developer, SRE, and SecOps tools. Panoptica ensures compliance with regulatory mandates and CIS benchmarks for best practice conformity. Privacy teams can monitor API traffic and identify sensitive data, while identifying open source components vulnerable to attacks that require patching. Proactively addressing security issues with Panoptica allows businesses to focus on mitigating critical risks and protecting their interest. Learn more about Panoptica today at panoptica.app. That's panoptica.app.
And we're back. And everyone, we have a really interesting conversation this week. As everyone knows, we've been talking more and more about AI and ML on this show. And we wanted to dig in a little bit into some of the both economics of AI and ML, as well as some of the barriers to entry. And so with us this week, we have Louis Ceze, co-founder and CEO of OctoML. So first of all, Louis, welcome to the show. And you have a really interesting background with roots in both the VC markets and academia. So tell everyone a little bit about your background, please.
Yeah, absolutely. Thanks for having me on the show, Aaron. It's great to be here. So I have a technical background. I spent most of my life so far doing research on making computers better. I came from Brazil 20-something years ago, joined IBM Research, building supercomputers for life sciences there. Went to grad school in making better parallel computers that are faster, more energy efficient, and easier to program. And then came to the University of Washington 17 years ago, joined the computer science department there as faculty, doing research on, again, computer systems and the intersection of computer systems and machine learning and even biology. So as part of that, I did a couple companies and been involved in entrepreneurship here in the Pacific Northwest, and being a venture partner in Madrona for the past 6-7 years or so. Yeah, I like to say that I have these three hats. My biggest hat is CEO of OctoML, and my other two hats are, being a professor of computer science, which is more of a lifestyle these days than an actual, 3 day-to-day job, and also as an investor in this space. So.
Oh, fantastic. Yeah. And it's funny because, I've done a number of startups, and we always say at a startup, you wear a number of hats. And now you're trying to say you do a startup and that's one hat of your many hats.
Yeah, that's right. And also, I mean, the OctoML started from research out of the University of Washington, research that led to high traction open source systems that we're going to touch on later today on making machine learning faster, more, energy efficient and easier to build. Anyway, so being a university spinoff also, makes it even easier to have these multiple hats. So.
Fantastic. Fantastic. So let's dig in. So first of all, I'll start with, generative AI is all the rage right now, right? But as most people start to dig into this of like, hey, how can I make this practical for my organization? I think a lot of folks really quickly hit some barriers to entry. And so I wanted to talk a little bit about that. So let's address some of them because I feel like you really have a very extensive history here. The first barrier to entry that I feel a lot of folks hit is just complexity, right? Where do you even get started? Do I need data scientists or not? And the tools I feel like have come a long way, and deployment models have certainly improved, but I think there's a lot of challenges of like, hey, how do I make this, thing we'll call AI and ML? How do I implement it into my production applications and the day-to-day life of my organizations? How do folks overcome that first hurdle?
Yeah. Well, so generative AI, by the way, most many people already know what they want to do with generative AI, right? So, yeah, you're right. There are several hurdles there, and the first one dealing with complexity is first of all finding a model that does what you want to do, or maybe we're going to talk probably going to talk more about training, training and fine tuning later. But assuming that they have a model and you want to put it in your workflow. The complexity comes from the fact that these generative AI models are very compute hungry and very performance sensitive, which leads to two things. First, a complex infrastructure to make them performant and deployable, and with the right resources to scale it. And then two, make them very expensive. And since they're expensive, the cost is a consideration when deploying them as well. Right. So the complexity of the infrastructure comes from the fact that you have multiple hardware choices, you have several pieces of underlying software infrastructure that need to come together to support the deployment of the generative AI models. It's getting easier today with several platforms, from several of the big cloud providers, as well as, OctoML offering a platform to make it very easy to add generative AI functionality to existing applications. So.
Yeah. And let's dig into that even a little bit further. Let's talk about that placement a little bit because, especially for folks that are new to this, I think this becomes another hurdle worth talking about, right? Because there's this concept of like, hey, we have to train the models, and that might happen somewhere. And then you have to fine tune the models, but think of it as like the first one being building the model, the second one being like iterating on the model, right? But then you have to run them as well. And all three of those steps could happen in very different places for very different reasons. And so can you talk a little bit about placement of the models, what you would put where, and maybe like matching infrastructure to it?
Yeah, absolutely. So, I mean, we live this day to day here, right? So let's just break this down a bit into a couple of dimensions here. The first one, the different types of models in generative AI, right? So there are, say, image generation models like Stable Diffusion or Stable Diffusion XL. They use a ton of compute. They're typically used in more interactive applications, so they have different requirements. Then you have models, large language models like, say, Llama or Llama 2, which are open source large language models for text manipulation. They have different compute requirements because of their actual, compute structure and how much compute they use. Okay. And then we think about training, fine tuning, and inference. They also have different requirements for several reasons. First, when you're doing training, you don't care about the latency. Typically, you don't care that it has to be done within seconds because you won't anyway. So you're talking about doing training over days or weeks. You care more about the overall compute capacity to go through your training data in a reasonable period of time, right? So fine-tuning is similar, even though fine-tuning typically takes on the order of, say, minutes, maybe hours. You care more about, do you have enough compute capacity to do your fine-tuning over the period of time that you have. But now when we talk about inference, you care a lot about the latency, right? Because often with inference, there's a human being on the other end, a user sitting there waiting for the answer to show on their screen. And there you have much more strict latency constraints to produce the output in a timely fashion to lead to good user experiences, right? So okay, so then there's these two dimensions, right? So training, fine-tuning, and inference, and then the types of models. And depending on what you're doing in this matrix of models and types of activity, you're going to map to different types of compute, right? So, for example, if you're doing training, it's not uncommon for folks to do training over an on-prem cluster or some pre-allocated compute capacity in a public cloud that they submit jobs and forget about it and see when they're done. Okay, so in that case, you do the placement essentially based on the GPUs that you have allocated in this kind of training cluster. And there's more planning involved, right? So you know how much training you're going to do, so you can provision capacity for that. Now, when you're talking about inference, for example, you're talking about things that first of all, because of the latency requirements, you're going to map this to GPUs or compute elements that actually have performance that you can actually hit a certain latency target before you deploy them. Right. So that's one of the things that we help users with. And I know people have to spend a lot of time as making sure that when they're going to put a model into production, is it going to have the user experience that they expect, and performance is at the center of that. So in that case, you're going to place them. Typically, people tend to overshoot and put it in a very high-end GPUs to have a higher chance of actually hitting that performance target, right? But the other thing with inference that's important to keep in mind is that you want to, mapping to compute resources that can be elastic. Because let's say that if you are a new hot generative AI startup, and then you have 10,000 users this weekend, you get really popular over the weekend, and next week you have 100,000 to 1 million users using your system. You have to be able to scale and scale fast. So and it's not going to have to do a lot of engineering until you don't have time to do a lot of engineering to go and onboard these other hundreds of thousands of users. But you have to be able to have your infrastructure scale. And in that case, you're going to pick compute resources, GPUs that are going to be able to scale with your demand, right? So, and as you know, this is a big topic right now. Yeah. Does that cover it? I know there was a lot there, but I hope that just think about the different types of things you want to do. The requirements and the type of models have a significant effect on how you place them. Yes. We can also talk about placing them on the edge too, but it might be a different conversation. You can even move models all the way to running to users' devices, which is a really fun technical topic that we might want to get into. So
Yeah, no, Luis, that's perfect. And well, I guess maybe one that's probably on a lot of our listeners' minds is you hear about, okay, GPUs are a lot of times, I won't say always required, but certainly one of the fundamental pieces of all of this, but you keep hearing more and more about GPU shortages. And so how does that play into the models as well?
Yeah, so it's a good question. So first of all, we need to provide the compute required by generative AI models, right? So these models are fundamentally compute hungry, right? So just as a quick aside here, Aaron, I don't know if ever stopped to think about the magnitude here, but to give you an idea, to generate one image on using Stable Diffusion, you're talking about trillions of compute operations. This is a 1 with 12 zeros behind it. There's a trillions of compute to generate one image. And if you're talking about using a large language model, like say a 70 billion parameter model, you're talking about on the order of 100 billion operations per word or token of output of these models. Just like a crazy amount of compute. Okay, so fundamentally we need to provide the compute required, right? So now let's talk about GPU shortage now. So there's a GPU shortage because people tend to want the latest and greatest GPUs, and those have limited capacity. You can't build data centers overnight, and you can't, even the most powerful cloud providers out there cannot move new racks packed full of GPUs fast enough into data centers to keep up with with demand for these high-end GPUs, right? So, plus there's some supply chain issues that pop every now and then that limits the output of the silicon manufacturing lines that produce new silicon, right? So, and I hope you don't mind me going all the way to the fundamentals here. So
No,
just saying,
this is perfect.
there's these physical limitations that place a restriction on how fast you can put new high-end GPUs online. All that said, there's actually quite a bit of capacity in the not latest and greatest GPUs that are there. They have, often good enough performance for what most people want to do, even with generative AI. They typically have better cost structures because, everything's supply and demand in the end. So one thing I like to say is that, yeah, there is a shortage of GPUs in general, especially on the higher end ones. But if you look at what's actually available in terms of raw compute capacity, there's a significant amount of compute available in the lower end GPUs. But the trick is they have to be able to use them, and that involves having to do quite a bit of low level performance optimizations and system optimizations to make a modern generative AI model run effectively in a usable way on a lower end GPU.
Yeah,
and that makes sense. Yeah. So yeah, this is why I want to give the nuance there. Is that okay, cool.
Yep, and I'll actually, that kind of goes when I'm thinking about this. What I really think about that is, okay, so it sounds like there's some of the lower ones are available, but again, it's the classic trade-off of cost versus performance that happens in our industry, right? There's probably real world trade-offs between cost and performance, and I'll throw complexity in there as well, right? Especially when it comes to building things out. And so tell everyone a little bit more about the optimization side of all of this. Like, what cost factors do you need to consider when you're thinking about hardware costs, for instance, or there's like data ingestion or data gravity that comes to mind, or another one is latency. And so you have to balance a bunch of variables here. Tell everyone a little bit about that.
Yeah, absolutely. So let's separate a bit, data and compute here, right? So so there are aspects of cost in data, and data has gravity because egress costs can be very significant. So if you talk about training, as you want to make sure that you're going to train as close to your data as possible. So first of all, you have the ability to read the data fast enough to do the training, but also if you stay within the same cloud, you're not gonna pay egress costs, right? So, but honestly, like the volume of compute involved in both training and inference at scale here is the lion's share is on compute, really. So the key thing is optimizing compute as much as possible. And it has many layers in the stack here. So, and several components. First is making sure you choose the right hardware that has the right unit economics for the things that you want to do, right? So you understand the workload requirements, you pick the right hardware, target harder types of GPUs or sets of types of GPUs that can do the job, that has economics that makes sense. Once you have that, the next thing is make sure you keep these GPUs fully utilized, right? So just like airlines don't like having airplanes on the ground because they're not generating revenue, having a GPU allocated that you're paying for, but sitting there not doing anything useful or just waiting for data to arrive or waiting for a job to be scheduled in it, like that's a significant source of cost inefficiencies. And that's something that people tend to overlook. Now, you buy a really high-end GPU only to realize that it's sitting there idle because you can't feed data, fast enough, or because you don't have good scheduling to keep it busy. So, anyways, finding the right cost structure, picking the right GPU, and then keeping utilization high. There's some of them. But now another one that's even closer to what we do here is really generating highly efficient code for the model that you want to run on the GPU that you have that you're going to run it on. Like different GPU architectures have different ways that they like to execute code, and generating really the right code and picking the right libraries, the right compiler parameters, the right code optimization techniques, and so on for a given model on a given GPU is extremely important. You're talking about 2, 3, 4, 5, sometimes 10x performance difference by doing things like that. And that does not change your model property at all. All it does is really makes much better use of the raw silicon compute and storage resources within the GPU architecture. Does that make sense? So
yes. Absolutely. And so the way I kind of think about this is like, let's say we're training a model and we get to an answer, but is that the most optimal way to get to that answer, right? And also, there's not just the fastest is the best way, because let's say you could get to an answer, but let's say you get to the answer slightly slower, but maybe it's significantly more cost effective, right? And so there's
exactly
lots
right,
of things there's just because you have the answer doesn't mean it's the only answer.
That's exactly, especially in AI workloads, right? So one of the fantastic things about AI workloads is that they do amazing things, but it's not that there's a precise only one output that's correct, right? There's several of them that are they're acceptable. If you don't mind, Aaron, like I think it's important for us to touch on a related topic too, is that just the compute diversity that exists today touches on complexity that you brought up earlier, right? So there's so many different types of hardware in which AI can run on today, right? So we focused on conversation so far on GPUs, but even just within GPUs, there's dozens of different GPU architectures. More of them, sure. NVIDIA is, the dominant provider of GPU parts today, but AMD has good GPUs that's going to start appearing on public clouds probably sometime in the next 6 to 12 months. There's all sorts of different specialized silicon that are not the typical GPU architectures, but are high throughput compute engines that are more specialized to AI workloads. So all of this points to a future that is going to be very diverse in terms of hardware targets, that fundamentally requires really good abstraction layers for folks to build on top of. Otherwise, there'll be a lot of inefficient engineering involved in making use of this infrastructure, right? So
yeah, and maybe a follow-up question to that is, do you see this dependence on GPUs continuing in the future? It could be NVIDIA, it could be AMD, it could be another company that's maybe not even out there yet. Will there be, you mentioned abstraction layer, right? Is there an abstraction layer or another technology coming that you have your eye on that will allow the industry to move away from this direct dependence on GPUs for mainstream applications?
Well, I mean, it's a good question. I mean, can we replace the word GPUs for high performance compute engines, parallel?
Sure.
Basically, GPUs are gigantic parallel computers on a chip, and you put a bunch of them together, right? So a GPU today is more powerful than the fastest computer on Earth. Maybe 10 years ago, 15 years ago, right? So, I find it interesting that we still call them GPUs. Even though I would say most of the cycles today do not go to graphics, they go to AI or simulations or high performance computing workloads, right? So, no, I would say that, there will be a dependence on very high throughput compute engines. That I have no doubt, because that's just physics, right? So we can't use CPUs, typical AMD, Intel, ARM CPUs, because they're very general, but they have a lot of overheads to execute general code. Like you put a bunch of CPUs together to be as flexible as they are, they're fundamentally not efficient enough to run the kind of compute required for the things that we're doing with generative AI today. Does that make sense? You might be able to squeeze a lot of performance and make them usable in some cases, but it's just not going to be efficient, because when you go all the way down to the circuit level, there'll be a lot of electrons there moving around. All they're doing is going to be, am I doing this work or that work? That's what CPUs do all the time. They do a lot of decisions before they do the compute. Whereas if you're talking about these more parallel compute engines, they're more constrained in what they can do, but then all of the electrons are moving around primarily to do the actual compute. Does that make sense?
Makes perfect sense. Yes.
So this is just a very long way, maybe professorial way of saying that what we are going to have here for sure is have a sea of highly parallel compute elements, that some of them look like what we see at GPUs today, but more and more there's architects like Cerebras, like GraphCore, Sembanova, that have a very different way of thinking about it. It's much more spatial than what the GPU architectures look like today, and those are starting to come online. They're going to have even more diversity, probably very different and a little bit harder to program, because is going to be new to most people. So we need abstraction layers on top of that fundamentally. So
nice. Yeah, and I'll go from the low level all the way to the high level for kind of our last topic here. I assume, and I'm going to ask you this, right? Do most organizations tend to use a off-the-shelf model, like an open source model today? And then do they basically take that model? Because I mean, I would imagine building a model is really hard. So, hey, let's go use a model that's out there. And then they train that with their private data. I would expect this to be the fastest way to production. You're like, why build your own model when the difference is in your data, right? And is that a correct scenario? And how do folks get into production and optimize for it as fast as possible today?
Yeah, no, it's a great question. Let's just zoom out for a second here, if we look at not too long ago, like in December last year, people were opening their eyes to ChatGPT and, turn everyone's attention of what a model like that can do, right? So I would say that today there's still quite a few, organizations just getting started by using a off-the-shelf but closed API model like OpenAI's models, for example, or some of the other providers like, Cohere or Anthropic and so on. But then, what I'm seeing here is a motion where people get started with these off-the-shelf closed models. And then once they know generally what they want to do, they go start thinking about, they need to control the data, or they want to own more of the model. They want to control their destiny there. So that's when they turn to either training their models from scratch, which might seem like a significant undertaking. But honestly, like the tools to do that are getting better and easier. And the cost, while still high, is not prohibitive, I would say. The question is expertise, right? And it is a question of why. Why would they do it, right? So again, to be reductionist for just a second, if you're going to train a large language model over a body of text, a significant amount of that is going to be just discovering how the English language works by the relationship between the words, right? So you're going to be learning that over and over again, regardless of what kind of data it is. And then after you learn the basics, you're going to start specializing that, language model to the topic that you're training it for, right? So this is what this points to what people are doing today, which is starting from an open source, base model like say Llama 2, and then fine tuning them to their use cases, right? Llama 2 changed the picture quite a bit because Llama 2 was one of those models that showed that people can get a lot of the really compelling capabilities that you typically had seen on closed models, but now seeing an open source model, right? So I know it's a long answer to your question, but the fastest way to get started is to use a closed model. But the most effective way, in my view, is to get an open source model, start using it, specializing it for the needs that you have, fine-tuning the model for what you need. And then now you have the benefit of owning the model, knowing what's there. You have transparency, you have control. So what you need now is a platform to run them on. And that's where Octo AI, OctoML's a product offers is the ability to get open source models, put them in production literally in minutes with highly optimized infrastructure that you typically see on the closed models, but apply to open source models, right? So does that was a long answer, but I hope it covered some of the topics.
That was perfect. Yeah, and I think that's a really good stopping point for us, because I think that's a fantastic summary of it all, because it shows the kind of evolution of this industry, if you will, of we're moving past building and training those when it's undifferentiated work, if you will.
Right, absolutely. And now there's such a fantastic set of open source models ready to be used in a lot of the key high value use cases like media generation, like text summarization, question answering. All of these key high value business use cases are covered by open source models today. And you controlling that deployment and gives also privacy and data flow guarantees that is harder to have on a closed API. So
fantastic. Yes, that's great. So Luis, I'm going to close it out from there. Where can everyone either find out more about you, find out more about OctoML, and what's kind of next steps for those folks that are interested out there?
Yeah, absolutely. I would just say come to octoml.ai. Learn about what we offer, and we have a self-serve platform called Octo AI. You can create an account there and get started literally in minutes. There's credits involved. You can get started right away without having to pay anything immediately. And there's several examples on image generation, on text manipulation that you can do without writing any code to get started with. And then there's several compelling examples that you can use for high value use cases that you can go clone and start building. So yeah, come and learn more.
Fantastic. Thank you very much for your time. So I'm going to close us out on behalf of Brian, who wasn't able to make it this week. Thank you, everyone, for listening. And of course, wherever you get your podcasts, if you have the ability to leave us a review, we'd certainly appreciate that. And certainly tell a friend about the show as well. We're always interested in more topics. If you have an interesting topic in mind, send us an email, show@thecloudcast.net. And so I'm going to close it out for this week. Thank you, everyone, for listening, and we'll talk to everyone next week.
Thank you for listening to The Cloudcast. Please visit thecloudcast.net to find more shows, show notes, videos, and everything social media.